Wow, good morning. I always say good morning. By the time you guys are awake, it's probably good afternoon or maybe good evening. Or I hope it's not Sunday evening, but Mr. Key is here to help you out. Ooh, he's in blue today. Should be in black and red, black and red. Got my Brugger's coffee. Ooh. Of course I do. Been up since 5:30, almost 6 o'clock. Finally got my computer running. God, I love this computer. I don't know if I've told you that before. By the way, if you haven't hit the subscribe button, please hit the subscribe button. Helps me out, helps you out. Doesn't really help you out, but helps me out. And since I'm helping you, you can help me. Here we go, kids. Right triangle trigonometry today. Now, I hope at some point you have learned how to find missing sides in your lifetime using that famous thing called the Pythagorean theorem. No, I'm not going to spell it because I'll probably spell it wrong. X squared plus 8 squared equals the hypotenuse squared. The hypotenuse is always found opposite the 90-degree angle. It's also the longest side of the triangle. Sometimes that's hard to figure out, but not often. At any rate, in this case, it's x squared plus 64 equals 289. Yes, I did that in my head. 17 squared is often done in mathematics. I don't know why. We just like to do it. Oh, heat's on. Lights flickering. My nose itches. My goodness, all kinds of problems. If I subtract 64 from both sides, I get 225. Now if I come through and I take the square root of both sides. Now normally when you take the square root of both sides, you have to put a plus or minus. But in this case, I'm not going to put the minus because it's a length. And lengths can't be negative. At least not unless you're in a black hole or something like that. So x equals 15. So let me put that on there. For some reason, there's something in my eye. Yes, I know. It's a pupil and an iris. All right, x equals 15. Now I can see. X equals 15. All right, so what we're going to do now is, now that we've got this 15, I'm going to kind of erase all the crap that I put on around here. Hopefully I'm going to. I want to go back to this diagram. I'm going to put this 15 here. And I want you to try to remember something you were taught. And I think it goes something like this. Some old horse caught another horse taking oats away. That's kind of boring. Some old hippo caught another hippo tripping on alligators. I don't care what you do. You have to learn these 3 trig ratios. At some point, you'll just know them. But most of the time, you'll be going through your head, some old horse caught another horse, or whatever mnemonic device you like to use. So then what you want to do, before you start to figure out what sine P, cosine P, and tangent P are, you want to label this diagram. So I always try to do opposite first. If this is our angle P, this is our angle P down here. We're going to put the thing here because I'm looking for P. If you can't see over here, I'm looking for what sine P is and what cosine P is and what tangent P is. So first thing I do is label this O, A, and H. Let me take out a different color. This would be O because it's opposite of the angle. The H is easy. That's the hypotenuse. And then whatever's left over, the adjacent side, which just means next to the angle, but not being the hypotenuse, is A. So in this case, if I want to know what sine is opposite over hypotenuse, 8 over 17. So I come over here and I say, okay, opposite over hypotenuse. Cosine is adjacent over hypotenuse, or 15 over 17. And tangent is opposite over adjacent. Opposite over adjacent, which would be 8 over 15. All right, 6 trig functions. 6 trig functions. You thought you only had to know 3. We've talked about our Greek letter theta. T-H-E-T-A. If you can't see that because behind my big head, it just says theta. Theta, theta, Greek letter theta. We use that oftentimes with angles. Let me label my diagram, O, H, and A. And we just talked about these three. Some old horse caught another horse tripping on alligators, taking oats away. Whatever you want to learn. These are the reciprocal functions. Cosecant, this is cosecant. Secant and cotangent. Well, if I call them the reciprocal functions. Now, the one thing that people don't like, and that's because we don't like you as math teachers, we decided to make things a little bit more difficult. Sine starts with an S, but its reciprocal function is cosecant, which starts with a C. And cosine starts with a C, and its reciprocal function starts with an S. And you're going to have to keep those straight. So in your brain, you got to say, oh yeah, math sucks. Math teachers hate me, and so they made it as hard as possible. So when I ask about the cosecant of something, you're like, oh yeah, that's the reciprocal of sine. So if it's a reciprocal of sine, then cosecant is hypotenuse over opposite. Secant then would be the reciprocal of cosine, so it would be hypotenuse over adjacent. Now cotangent is pretty easy. It's just the reciprocal of tangent, which is adjacent over opposite. Now these two other boxes, these are your first trig identities that you have to memorize. And that is that tangent of theta is equal to sine theta over cosine theta. Memorize it. It's your first one you have to memorize. Memorize it. You do not want to be at the end of this unit not having memorized a lot of the things you're going to have to just commit to memory. And by memorize, I mean commit it to your memory, not just go, oh yeah, I got it, sine over there, sine over, I'm done. Well, if cotangent is its reciprocal function, it should be pretty easy. It's just the reciprocal of that, cosine theta over sine theta. So if you know this one's just the reciprocal of it, so it's not too bad. So how am I going to use this to ask you a question for a test or a quiz to make sure you know how to do it? I'm going to give you something that looks like this. I said, okay, you've got sine theta equals 5 over 13. So if you wanted to, you could come over here and say, okay, cosecant theta is equal to then the reciprocal of that, which is 13 over 5. And I'd say, okay, what's cosine theta equal to then? And what's secant theta equal to? And what's tangent theta equal to? And what's cotangent theta equal to? I don't know. But we're going to find out. So what we want to do is first draw a triangle. We want to draw a right triangle. This is the basics unit, so we're only going to be working with right triangles. Eventually, we're going to step things up and stop just working with right triangles. It gets a little more difficult. When it gets a little more difficult, drink Brugger's coffee. It makes math easy. Okay, that was a lie. I was just kidding about that. Doesn't do anything. But stunt your growth if you're young, so don't drink it when you're young. Anyway, if you remember correctly, sine theta is opposite over hypotenuse. So let me grab a different color. Say, okay, this is my angle. This is opposite over here. So we know this is 5. This is my hypotenuse here. This is 13. And I got to find my adjacent side. I could just go through into the Pythagorean theorem, or I can remember what a Pythagorean triple is. The most famous Pythagorean triple is, you got it, 3, 4, 5. Now, of course, I can do any multiple of that, like 6, 8, 10. I just multiplied everything by 2. I can multiply everything by 3, multiply these by 3, 9, 12, 15. I can keep going forever and ever and ever. That's one of the famous Pythagorean triples. The other one is the 5, 12, 13 Pythagorean triple. And of course, this one you can double to. This is a Pythagorean triple. That's a Pythagorean triple. But this is the one we need right here. We've got a 5, and we've got 13 as the hypotenuse. So our missing side must be 12. Now, if you didn't get that, or if you don't remember the Pythagorean theorem, don't worry about it. Or you don't remember the Pythagorean triples, don't worry about it. You can always use the Pythagorean theorem. So, what do we need? We need cosine. Cosine is adjacent over hypotenuse. That would be 12 over the hypotenuse 15. And this is the reciprocal of that, 15 over 12. Tangent is opposite over adjacent, so that would be 5 over 12. And its reciprocal function, cotangent, is 12 over 5. Hopefully you see that. All right. Put this way up here so you can see it. All right. A stake is to be driven into the ground from the base. A stake is to be given on the ground away from the base of a 50-foot pole. A wire from the stake on the ground to the... So all we're going to do now is just solve some simple trig equations. There's my ground. There's my pole. There's where I hammered in the stake. We know my pole's 50 feet. And we know in order for this to be safe, this wire right here has to make an angle with the ground. Now, oftentimes what I'll do is the wire makes with the ground. And I'll say, okay, here's the wire. Here's the ground. Okay, here's the angle we're talking about, theta. And we said that's got to be 52 degrees. Okay, next thing I'm going to do is come through, label my diagram, opposite, hypotenuse, adjacent. Now, here's the question right here. How far from the base of the pole should the stake be driven? And if you can't see this, this says nearest foot. Let me move it over. It says to the nearest foot. So, I don't want to know the length of the wire. I don't care about the length of the wire. Some old horse caught another horse tripping on alligators. I want to know what this is. So I'm going to call this my x. And I didn't mean to put like an x there. I just meant to get rid of that. So what I always ask the kids is, I always say, okay, kids, what two sides are in play? Well, we've got the opposites in play. And since I'm looking for the adjacent, it's in play. And I have the angle. You'll notice you'll always have 2 out of the 3 things. And if you don't have 2 out of the 3 things, you have to find enough to get 2 out of the 3 things. So I know that I want to use O and A. I want to use tangent. So I'm going to come down here and do my work. Oops. Tangent of 52 degrees is equal to opposite, which was 50, over adjacent, which is A. 50 over adjacent, which is, in this case, we called it x. We just don't know what it is. So, at this point, we're just going to solve this simple equation by either cross-multiplying or looking at them and finding the common denominator. The common denominator is x. I'll multiply this side by x, and I'll multiply this side by x. So I get x times tangent 52 degrees equals, these cancel, 50. Now, I'm just going to warn you, do not put things into your calculator until you have the variable solved, or you've solved for the variable. Since I still have this over here, I'm just going to divide by tangent 52. I don't want to know what tangent 52 is. I don't care what tangent of 52 is. It's somewhere near 1, but I don't care about that. And I get x equals. Now I take my calculator out, and I'll do 50. Now I'm going to go to calculator mode. You have to make sure you're in degree mode. See this up here, degree mode. If you're not in degree mode, you click on it. You go into document settings. You click on this. You go to degree. You choose make default and choose yes. So I want to do 50 times, and right in here is tangent. Tangent of 52 degrees. And I hit enter. That's not what I had. I had 50 divided by, I'm having a hard time, I just put it in wrong. 50 divided by tangent. Okay, tangent 52. I'm in a hard, yeah, I love my computer, right? So this is what I had, 50 divided by tangent of 52, and I get 39.06. So x equals 39.06. I like to give lots of decimals, 4281. 4281. And then I say, okay, nearest foot, that would be the nearest foot. I don't round because it's a 0, so the answer is 39 feet. Done. All right, that problem's over with. Ron and Francine are building a ramp for performing skateboard stunts. The ramp is 7 feet long and 3 feet high. Ooh, the inverse of sine is sine -1 of x. Oh, I think in class I asked you about that, and I thought I said inverse is sine -1. So let's see. We've got the ground. We've got a ramp that's 7 feet long, and it goes up 3 feet high. The question says what is the measure of the angle to the nearest tenth of a degree? You can't see that, probably behind my big head. Tenth of a degree. So we're looking for theta. Some old horse caught another horse taking oats away. So let's see. Let me label this thing. Opposite, hypotenuse, adjacent. So let's see. Let's see which, you got to see which two sides are in play. What do I mean by in play? Well, I like that one. It's got a number. I like that one. It's got a number. This one's got nothing. I don't need it. I don't even want it. I don't even care about it. The only thing I'm looking for is, in this case, I'm looking for my angle. So the two sides that are in play, are O and H. O and H says use sine. So I know that sine of theta is equal to opposite, which is 3, over hypotenuse, which is 7. Now I have to get theta all by itself, which means somehow I have to get rid of the function sine. You're not allowed to divide by functions. No, that doesn't work. For those of you that like to divide by sine, by the way, that's sine, not sin. Sin's what you go to church for, or the confessional for. Sine is what you go to math class for. So I need to get rid of that sine somehow. So what I'm going to do is, let me just take you back on a little history, little trip. If I've got x squared equals 20, and I said, what's x equal to? You'd say take the square root, put a plus or minus, and you'd say x is equal to plus or minus the square root of 20. I'm not going to simplify that. What if I said the square root of x is equal to 8? And I said, oh, we got to come through and we got to square both sides. And we'd say, okay, x is equal to 64. These are reciprocal functions. Not reciprocal. These are inverse functions. Square and square root. Square and square root. They're inverse functions. So when I want to get rid of a function that I need to get rid of, I need to use its inverse. So what I'm going to come through and do is I'm going to take the inverse of this. Well, the inverse of sine is sine inverse. But if I take sine inverse of the left side, then I have to come through and I have to take sine inverse of the right side as well. So in other words, I get theta is equal to sine -1 of 3/7. And that I can put in my calculator. Now, I think most of you are going to have a hard time remembering to do all this and craziness. I think I want to get you to a point where you're just doing the math. And so you understand where it comes from. But if you end up with sine theta equals 3/7 in the future, I want you to think about this. Think about this. Think about if I had x plus 5 equal to 0. And I'd say, okay, solve for x. Wouldn't you move this from here to here? And when it moved over, it became negative 5? Right? So when something moves from one side to the other, we get it negative. So that's what I want you to be thinking about with sine. I want to move this over here. If I move it over here, it becomes sine -1. We change the sign. Now, that's not in effect what we're doing. What we're really doing is taking the inverse of both sides. But this is kind of an easy way to remember how to do it. Now, when I go to my calculator, I just do trig sine inverse of 3 divided by 7. And I get 25. Now, if you get something ridiculous, you're probably in radian mode. Go back up here and look. Am I in radian mode? 25.3769. Theta equals 25.3769. 33. And find the nearest tenth of a degree. That's there. So theta equals 25.4 degrees. All right, kids. Now, on this one, I'm doing them all. In class, I did not do them all. Let's see. I want to find x. So I label my diagram O, A, and H. The two sides that are in play are O and A. I come up here and I say O and A. O and A is tangent. Okay, I guess I got to use tangent then. So tangent of theta is equal to, I think it's 420. Opposite, which is 420. I don't know if you can see that behind my head. 420 opposite over adjacent, which is 2000. We're going to bring this tan over here and put it there. So when it goes over, it gets a sign change. So it becomes tangent -1 of 420 over 2000. Let's come over here. My calculator. Tan inverse of 420 divided by 2, 1, 2, 3. I think I got too many. Enter. I get 11.8597. So theta equals 11.8597 rounded to the nearest, I think, degree. So theta equals 12 degrees. This is what I want to find the height of this tree. So the first thing I'm going to do is label it O, A, and H. O, H, and A. Oops, we're using tangent again because the two sides are in play are X here, which is the height, which is opposite, and A. So tangent of 62 degrees. I'm going to do it right here so you can see it. So the tangent of 62 degrees is equal to opposite, which is X, over hypotenuse, which is 15. I'll come through and multiply both sides by 15. Those cancel, and I get 15 times tangent 62 is equal to X. And then I'm just going to write X equals whatever my calculator says. 15 tan 62. 15 times tangent of 62. Tangent. Gotta love my calculator. 62 on my computer. Probably going to crash. 62 is 28.21 degrees. So theta equals 28 28.210,896 rounded to the nearest. Oh, that's not so foot. Rounded to the nearest tenth of a foot. So x equals 28.2 feet. That's it, kid. By the way, this assignment can be found on MrKrausMath.com. Just go to one of my sets and choose day 2. All right, I'm going to guess. I think I'm going to take a fair guess. How high above the ground to the 10th is the top of the ramp? So I want to know the height of this wall. So let's see. That's opposite and hypotenuse. And if I remember correctly, that's some old horse. Sine. So sine of 32 degrees is equal to opposite, which is x, over hypotenuse, which is 30. All right. Get a cool color in there. I'm going to multiply both sides by 30. There you go. And this is what I just put in my calculator. 30 sine 32. 30 times sine 32. Let's see if this crashes. 15.897. X equals 15.897,577 to the nearest tenth. X equals 15.9 feet. And we're done with that page, kids. Yay! It just never ends. The incline of a ramp is used for loading the truck is 11 degrees, as shown below. The incline of the ramp to use, find the nearest tenth of the length of the ramp. So we need to find the length of the ramp. So in this case, we're looking for x. We've got two sides in play, this side and this side. So I'm going to label them, O, A, and H. This would be opposite. This would be hypotenuse, and this would be adjacent. So in this case, I want to use sine because I got O and H. So sine of the angle, 11 degrees, is equal to opposite, which is 2 over hypotenuse, which we called x. So what we're going to do is we're going to come through and multiply both sides with a common denominator. Common denominator in this case is x. We're going to multiply this side by x and this side by x. So what I get is x times sine 11 degrees is equal to 2, because these cancel. Divide by sine 11. And now I go to my calculator. If I seem a little distracted, I am. I apologize. One of Hilton's former students passed away last night. So I'm a little distracted. I apologize if you haven't seen the news or if you're watching this at a different time. So he's a kid I really liked. He was a nice boy. Really good athlete. Nice kid. Don't know what happened yet, but so I'm a little distracted today. So I'm not as my peppy, cheery self. I'm trying, but I'm not as my peppy, cheery self as I am if I would be if that hadn't happened, because he's the same age as my kid. Okay, x is equal to 2 divided by sine 11. So we're going to do control division 2 divided by sine 11. 10.481. So x is equal to 10.481 686. And so I get x is equal to, said round to the nearest tenth of a foot, 10.5 feet. All right. I'm trying, kids. I'm trying. 18 years old, 19 years old. I don't even know what his family's going through. All right, I'm back. Let me see if this is recording. All right. I want to find this angle. Another question I asked in class was, I said, okay, how much shorter is it to go directly from New York to Buffalo than it is to go the roundabout way? Well, the roundabout way is pretty easy. That would be just 280 plus 170, 450 miles. And to find this one, I would have to use the Pythagorean theorem. 170 squared plus 280 squared equals, and we'll call this y, I guess, y squared. So I go to my calculator and I go, okay, 180 squared plus, no, Jesus, 170 squared plus 280, I don't know, 280 squared equals, so that's 107,300. So 107,300 is equal to y squared. So now I take the square root of both sides. I take the square root of that, and I go, okay, 327.56. So y equals 327.56. And I said rounded to the nearest mile, so y is equal to 328. So I said, how much shorter is it? It's 122 miles shorter. Just subtract those two. So now I want to find x. And I've got O and A. So obviously we're using tangent of x is equal to O, which is 280, over x, which is 170. But since I want to find an angle, I got to get rid of this tangent. So I'm going to bring it over to the other side, and it becomes tan negative 1. Leg. So I go x equals tan negative 1 of 280 over 170. And I grab my calculator, and I go tan negative 1 of 280 divided by 170, and I get 58.736. So x equals 58 point, cannot keep things in my head, 736.263, 268, something like that. So rounded to the nearest degree. So x equals 59 degrees. All right, kids, next one. We want to find the height of this kite. Let's kind of speed things up a little bit, because otherwise this video is going to be like 10 hours long. So first thing I need to do is find this length right here, which is x. I'm going to call that x. Now that's opposite, oh my gosh, an adjacent, so that's tangent again. But this time we got tangent of 50 degrees is equal to x over 95. I just come through, and I'm going to multiply both sides by 95. Multiply both sides by the same thing. These go, and I get x equals, and then this is all I'm going to type in my calculator, 95 tan. So 95 tangent of, I have no idea, 50 degrees equals 113.216. 113.216. Round and there's foot. So you might say, oh, x equals 113. But we got to be careful here. 113 feet. You got to be careful here. That was this height to here. From here to here. The height of the triangle, or the height of the kite, is from here to here, which is 3 feet longer, because we got to account for this 3 feet high. So the actual answer is x equals 116 feet. All right, kids, that was number 9. We only got, how many we got here? See, we got 8 left. Moving on down. Ooh, crap. What is the measure of angle A to the nearest tenth of a degree? A. So I got to come over here. We're going to find it over here. Angle A. Well, we can use anything. Let's use opposite and hypotenuse. So that would be sine. So sine of A is equal to opposite, which is 11.2, over adjacent, which is 21.5. Slide the A over. So A is equal to sine inverse of 11.2 divided by 21.5. 11.2 divided by 21.5 equals 31.39. That's interesting. That came out to 39.4. So that, I mean, this obviously has to be the answer, I guess. But wow, that number is off. What if I use these? That would be cosine, right? So cosine of A is equal to 18.3 over 21.5. So let's see. Inverse cosine of 18.3 divided by 21.5. 31.7. Oh, that's the better one. Okay, there's the answer. 31.7. That was kind of a crazy problem. I don't know what happened there. So if you read through this problem, it said that this wire, I mean, you should pause it and read through it. I've read through it already. It says this wire S and R is 50 feet long. And they want to know what this angle is, X. Well, here's another classic example of you need 2 out of 3 things. 2 out of 3 things. You got to have 2 out of 3 things. So if I'm looking for this angle X, this is O, this is hypotenuse, and this is adjacent. I have O, but I don't have the angle, and I don't have one of these 2 sides, so I can't really even work in that triangle. Now, if I come over to this triangle, oftentimes when you have multiple shapes, you have to work in the remote or the furthest away triangle. If I work in this triangle over here, I have this, and I can find this. Well, that's 16 squared plus 12 squared equals R squared. R is equal to 20, and I know that because these are multiples of the 3, 4, 5 right triangle. If you did the work, you'd find out R is 20. Now, if I go back into this idea that the 2 cables add up to 50 feet and this is 20, then this has to be 30. Well, now I have 2 things in this diagram. I have O and I have H. Some old horse. That's sine. So I want to do sine of X equals 16 over 30. Inverse sine, bring that over here, so I get X is equal to inverse sine of 16 divided by 30. Go to my calculator. Sine. 16 divided by 30. 32.23. X equals 32.23095. So X is equal to, what? Rounded to the what? Nearest degree? 32 degrees. Ka-ching! Whatever. Done. Find the height of the tower. X. Opposite. Adjacent. Don't care about the hypotenuse. Opposite adjacent is tangent. So tangent of 78 degrees is equal to opposite, which is X, over adjacent, which is 25. Come through and multiply both sides by 25. And I get X is equal to 25 times tangent of 78. 117.615, 117.615, 752. Sorry, my dog's down here. X equals, round the nearest tenth of a foot, 117.6 feet. Moving down, kids. Getting close to the end. Find the nearest degree to measure the angle of the wire with the ground. So wire, highlight it, ground, highlight it. We need to find this. So that's opposite over hypotenuse. I didn't use cosine today at all. That's weird. We'll call this x. So sine, because we know sine is opposite over hypotenuse of x, is equal to opposite, which is 30, over hypotenuse, which is 50. Didn't I just do this? Oh, no. So slide this over, sine inverse, so x is equal to sine inverse of 30 divided by 50. And you actually have to show that you're doing that. You can't just put that in your calculator without showing the grader that you know what you're doing. That's redunculous. 30 divided by 50. It's 36.869. X equals 36.869. Or x is equal to, nearest degree, 37 degrees. Moving down, kid. Last page. In right triangle ABC. Well, I don't see right triangle ABC, so I'm going to draw right triangle ABC. Now, it makes kind of a difference where you put things. I need to know what's the right angle. Angle C is the 90-degree angle. The other two don't really matter. So A, B, C. So AB is 20. AC is 12. BC is 16. Find the nearest degree of the measure of angle A. Well, since it doesn't matter which trig function we use, and we haven't used cosine really at all, I'm going to use adjacent and hypotenuse. So cosine of A is equal to 12 over 20. Going to slide that cosine over. So A is equal to cosine negative 1 of 12 divided by 20. Or A is equal to 53.130. 53.130. 102. Round to the nearest degree. A is equal to 53 degrees. Moving down, kids. A surveyor needs to determine the distance across a pond. She determines that the distance from her point to position P is 175 meters, and the angle from her position to the X is 32 degrees. Find the distance across the pond. Opposite and adjacent. By now you know the function tangent. We've killed that one in this. So tangent of 32 degrees is equal to opposite X over adjacent, which is 175. In order to get the X by itself, I'm going to multiply both sides by 175. So X is equal to 175 tan 32, 175 times tangent of 32 degrees, 109.35, 109.35, 213. X is equal to, nearest meter, 109 meters. All right, two left, kids, I think. A 28-foot ladder is leaning against a house. Oh, well, that's got to start from the ground. Here's my house. Yes. Ooh, you want to put some windows? Not in the mood. There's my ladder. It's 28 feet. I put it 6 feet away. Okay, that doesn't really look close to being accurate. So let me. So there's my ladder, and let me label this in a different color. It's 28 feet. My ladder put 6 feet away. What angle does it make? Theta. Well, I label it O, H, and A. And I'm using A and H are in play. Well, if A and H are in play, that's cosine. So cosine of theta is equal to 6 over 28. Bring the cosine over by taking the inverse cosine of both sides. So cosine -1 of 6 divided by 28. Bust out the old calculator. I'm just going to tell you theta is equal to 78 degrees. Last problem. So again, you need 2 out of 3 things, correct? Don't think I have. Wait a second. This is a rectangle right here. So if this is a rectangle, this distance here is 28. And this whole distance is 36. So that would make this also, well, 36 minus 28 would be 8. So this is 8. And the question is, what's the angle x? So I got to label this thing O, A, and H. Grab one of my favorite colors, blue. This is O. Now it's O because it's the opposite of this. This is H, and this is my A. So since H and O are in play, I know that's sine. So sine of x is equal to opposite over hypotenuse, which is 12. Slide this forward. So I get x is equal to sine inverse of 8 divided by 12. And I take out my calculator. And I go, okay, sine inverse of 8 divided by 12, 41.81, 41.810, 314. Round to the nearest tenth of a degree, x equals 41.8 degrees. And that's it, kids. That's the end of day 2 in the trig unit. I hope you thoroughly enjoyed this hour-long video. I believe it was an hour long. I don't know. Oh, my goodness. 47 minutes of fun. Kids, hit subscribe, hit like, and take care of each other.